Today's lesson is 3-8 scatter plots and trend lines. It's the very last lesson of unit 3, and next week we will be starting unit 4. So the first thing that I want to go over is some of the vocabulary. Okay. So a graph that relates two different sets of data by displaying them as ordered pairs. This is just another type of graph, and it's called a scatter plot. I believe you did. Okay, then you have something, because your dots are scattered all over the place, and if you look at these graphs down here, you'll see these 5 right here. Notice there's not, it's not a linear equation that's been graphed. So when we want to find an equation of a scattered plot, we have to find something called a trend line, or the line of best fit. And basically you take that line, you draw a line in the middle of your data that touches as many points as possible. Okay, so we call that a trend line, or line of best fit. Best fit. Okay. Okay, the next line is, or the next vocabulary word is correlation. We can use the word correlation the same as we might use a relationship. So this shows the relationship between two sets of data. This relationship or correlation can be positive, negative, or there could be no relationship or no correlation. So if you look down here at the graphs, there is a perfect positive correlation. We can say that this graph right here shows a perfect positive because it's linear. That means it's a perfectly straight line, and it's going in the positive direction. This one shows a positive correlation, and it's highly positive because the lines are close together in the positive direction. But then notice this one. These points become further apart, so it's a low positive correlation, but they're still somewhat flowing in the positive direction. This middle graph, though, there's no correlation at all. They are scattered all over the place. So really, there's no correlation. And you'll see that this down here, you see a little R down here. I'll answer your question in just a second. The R stands for a correlation coefficient. It's a value between -1 and 1 that kind of describes what your line is. If your line is a 1, that means it's a perfect positive. If it's a -1, it's a perfect negative. If it's a 0, there's no correlation at all. If it is somewhere between 0 and 1, there is some form of a positive correlation. If it is somewhere between 0 and -1, it is somewhat of a negative correlation. Okay, and so this last word up here is correlation. Coefficient. Now, there is a way of checking on a calculator what the exact correlation coefficient is, but for Algebra 1, we are just going to estimate that correlation coefficient. So looking down here, if we have a positive correlation, that means our variables will both increase or both decrease. So down here, variables, which could be represented as X and Y on a graph, will both increase or both decrease. Okay.
This is like kind of off topic, but like the way you write your ands, I write it like the other way. Like
oh, yeah, it's fine. Either way, I guess you can.
Am I doing it wrong for these like 5 days of my life?
No, maybe I'm doing it wrong. I don't know. Okay, a negative correlation, one variable increases while the other variable decreases.
Is this an actual lesson we can use in the real world?
Yes.
If there is no correlation, every lesson, I get that question. Your variables
Every lesson?
from Jackson, yes,
Very fine.
are not related. They have no relationship. So that means that your R will equal 0. Okay. All right. So that is our vocabulary for the lesson today. Now we're going to go ahead and go on to page 2. So the first part of this is going to be determining whether a situation is, if two variables are associated and if they are, is there a causal factor? So when I say association, what that means is that the two variables are related, but one doesn't necessarily affect the other. So they have some form of an association. When I say the word causation, I'm saying the two variables are related and one will directly affect the other.
Why do so many words?
So that when we're describing the scatter plots, we're using the correct vocabulary.
On our quiz, we have to know these words.
Yes.
Oh.
And then causal relationship. When one event causes the other event to happen. And so we're going to look at two different scenarios. And then we're going to come down to the bottom and look at 3 additional ones and see if there is an association or causation. Here we go. Example 1, if you exercise, the calories burned per minute increase.
True.
So is that a positive, negative, or 0 correlation?
Positive.
Positive correlation.
How could it be 0?
We'll get to that. You'll see an example of one. So my next bullet point here is asking, is there a causal relationship? Does one cause the other to happen? Yes. So there is a causal relationship.
But why wouldn't it be a causation relationship? Or not just, why wouldn't it be causation?
It is. It's the same thing.
Oh, okay.
So it exists because the exercise causes the calories to be burned.
Okay.
Because there's a causation there. All right, the number of firemen fighting a fire increases as the size of the fire increases. Is that a positive, negative, or no correlation? Positive correlation. And however, a causal relationship does not exist, and I'll explain this. So let's write this in. And it does not exist because bringing more firemen will not cause the size of the fire to increase. It will cause the size of the fire to hopefully decrease, right?
So what's that be negative?
Well, you have to look at it as the number of firemen fighting a fire increases as the size of the fire increases. There's a positive correlation between that one, but the number of firefighters increases does not cause the fire to increase. So there's not a causal relationship when you look at it from that perspective.
But isn't it saying as it increases, so as the fire grows in size?
But
more
the
people come in to
firemen
help?
don't make the fire go.
But
Yeah.
it doesn't say it.
Yes, it does.
It does?
That's what this statement says right here. So let's look at more examples.
Yes.
Okay. The number of loaves of bread baked and the amount of flour used. Okay. Is there a correlation?
Yeah.
Yes. What type of correlation? Positive. Okay. That's all we're going to write on that one. Is there a causal relationship or a causation?
Yes.
Yes. If so, describe. And when we describe, how would we describe this?
The more bread you want, the more flour you need. And the more
The more ingredients used.
Okay, so I had 5 of you talk. Oh, that's great. Okay, so the more bread you bake, the more flour you use. And you can put that in your own words.
I have a question.
Okay, wait, hold on, let me pause. All right, example 4, the amount of time you study for a test and the score you receive.
No, that does not.
Yes,
Not
true.
You can study for 4 hours, but if you study the wrong material,
You're not gonna get a good grade.
Let's use
A smart child.
Yes.
a typical situation. If you're studying for the upcoming Unit 3 math test and you're studying the right material, the longer and the more that you study, the more likely that you will perform better.
Yes.
Okay? Is there a correlation? Yes. It is positive.
Totally choke.
Or you can just have a brain fart and not remember anything.
Is there a causal relationship?
Yes.
Yes. The more you study,
The higher your test score will be.
Mhm.
The more likely.
yeah.
Yeah.
Now that the science test is over, like school feels like easy.
Yeah, I know.
Life is good again.
Yeah.
Until the next one.
Okay.
Until history tests.
Oh my, no.
History tests are that bad.
Yeah.
But he's a study guy now.
Let's look at example 5, a person's height and the number of letters in a person's name.
True.
Wait, there's no correlation.
No correlation.
Short. We can have 6 letters in my name. And I'm not 6.
And is there a causal relationship? No, no causal relationship.
I have 7 letters. That's why Miss Soma is so tall.
No, Giannis.
And Giannis on top of the
All right, we're on page 3 now, and now we're going to start getting to the graph part of it. The table shows the altitude of an airplane and the temperature outside the plane. We're going to make a scatter plot of the data and describe the relationship the scatter plot shows, okay? So when you're graphing these scatter plots, they do get a little bit confusing because the numbers aren't going necessarily from 0 to 50 and in order, or from 70 down to 0 and in order. They're scattered all over the place. That's why we call it a scatter plot. So I want you to think about the airplane. It's up in the air, and the higher it goes, the higher the altitude. And the higher it goes, what's happening to the temperature? What do we know about that from science? It's
No,
getting colder.
it
The
also
temperature
gets
is dropping. The temperature is dropping. So
In different layers.
Yeah.
Changes. Yeah.
yes, in
troposphere.
different layers. Okay, so what, listen up. The higher you go, the higher, the lower the temperature gets. So we are going to graph this information here. Now, the title of your graph is the title of your table. This is going to represent your X, and this is representing your Y. So when we fill this out, plane altitude, and I'm going to abbreviate, and outside temp. Okay. On the X-axis, that's my altitude. It's going from 0 to 5,000. So what I'm going to do is I'm going to go up by 500s. Yes.
Wouldn't as the altitude increases, the temperature increases as well? Because at 1,000 feet, the temperature is 61, and at 500 feet, the temperature is 59.
But in the mesosphere, it's colder.
We're not talking about.
We're not in
meters.
science.
We're just doing a
It's
hypothetical.
like up and down. And it's not like a
Scenario.
Yeah, and so that's why this
Oh,
that's why this is going to be a scatter plot.
Okay. I understand.
Okay, so this is 0. This is 500. This will be 1,000, and I'm going to write every other one.
What if we did it on the other side?
Wait, you did 1,000.
Yes.
Miss Weatherman, what if we did it on the other side?
Then fix it.
Well, X always goes on the bottom.
Okay. And then I'm going to title my x-axis altitude. Okay. On the y-axis, I'm going, my lowest number is 0.6 and my highest number is 61.3. So I will be going up by 5s on the y-axis.
Are we skipping a line, everyone?
No. And we will need to label that temperature. Okay. Now what we're going to do is go through and plot your points. And this is where it could get a little bit tricky. When I plot my points, I'm going to go 0 up to 59. And so we're going to have to do a lot of estimating here.
Okay.
So it's not going to be perfect. And then 559.2, 1061.3.
You didn't.
You put all of them.
Yep, plot all your points. Hmm.
2000 is 41.
I'm a little confused.
Yeah.
Cause on 1,000.
Mhm.
Never mind.
So, man, do you ever get tired of your job?
No, not of teaching math, I don't.
Mark,
What
do you
about
ever get tired of
science?
us?
No.
Why not?
I would.
Okay, so once you have everything graphed, remember I talked at the very beginning about a trend line. Now, a trend line is a line that goes through the middle of your data and touches at least 2 points when you're graphing by hand. It doesn't necessarily have to touch 2 points if you're not graphing by hand, if you're using a graphing calculator, but we want it to as we're graphing. So
Grab a different color.
we are going to, so sometimes what I do is I draw a circle close to my data points or an oval,
So like the word search circle.
and I take my ruler and I put it in the middle of that circle and then adjust it so that it's touching a couple of points. Okay. It helps, but you don't have
Looks
to.
like the Hertz for the rest of the night.
Okay, and then I draw my trend line.
Oh, I
Okay.
chose two different points.
That's okay. And this is how you would create a scatter plot and then draw the trend line.
Okay, trend line done.
So in looking, Ali was right, or some of you were right. At first, the temperature gets higher, but then eventually when you get higher, out of the
No, stratosphere.
stratosphere, okay, then it starts to get lower.
Either
One of the
So
spheres.
highly
One of the
negative,
spheres. Okay, so what?
No, the exosphere.
highly negative.
It is a highly negative relationship. So I'm just going to put negative. And then next to negative, I'm going to estimate my correlation coefficient. What do you guys think that's going to be?
I think
It's going to be close to -1.
okay, so negative point eight.
Yeah, we could
Negative
do
correlation.
negative
Negative
0.8 or 7.
How'd you get that?
Okay.
We just guessed.
Remember the graphs on the front, these right here. We're just kind of looking at them. It looks very close to this graph right here.
I think it looks the three.
No,
Okay.
Jackson, it's gonna be in from positive to -1.
I know.
Okay, as
I think you know that.
temperature decreases, altitude increases. Okay, is there a causal relationship? Does
Yes.
the altitude cause?
No, because that person doesn't, and it does. So
The
Yeah.
plane isn't caused the altitude.
In the plane,
that's all.
The higher the altitude does not cause the temperature to decrease. The altitude itself does not cause the temperature.
Oh.
Okay, so there is no causal relationship. And we have to explain, I didn't give you enough room, so just right below it.
This takes so long.
how many questions are the homework?
The higher altitude does not cause temp to decrease. All right.
Would it have to be constant would it have to be constant for it to be a causal relation? Because would it be a causal relation if it has zeros at 59, 500 is at like 58, 1000 is at like 57, and it kept going down from there? Not by exact numbers, but it just kept going down. Would that be a causal relationship?
No,
Why not?
because still altitude is not causing the temperature. There's not.
What? Well, as the, oh,
On this next one, example 7, I need to explain it before you start graphing because the X and Y is flipped. The table shows the amount spent on gasoline purchases and the number of gallons purchased. Make a scatter plot of the data and describe the relationship the scatter plot shows. So this is the amount of dollars you spend, and these are the gallons that you buy. Which causes the other? What would be your independent?
the more gallons you buy, the more money you spend.
The more money you have, the more gallons you buy.
So the gallons, the dollars spent depends on how many gallons you buy. So this is your Y and this is your X. It's flipped in this graph. So be very careful when you plot your points.
That's confusing.
Yes, it is. But sometimes you will see that. So what I want you guys to do is I want you to go ahead and graph this data on here, and then we will describe it. Okay, so this is what your graph should look like. And what type of relationship do you see?
Positive.
Positive, yes. And the correlation coefficient would probably be close to 0.9, positive 0.9. Okay, and we could describe this as gallons bought increases, dollars spent increases.
Why is that looking?
We have to draw the line.
Yes.
Dollars spent.
Can it go both ways? Like, it's like the money spent, as money decreases, your gallons can increase, right? Because like the more you spend, the more money you lose, but the more gallons you're gonna have.
You're just looking at it from a different perspective. Yeah.
So it could be both for everything. You would change the answer though, right?
Yeah. You have to look at, like, in
We're
this
trying
one,
to
we're
get that
talking about
information.
dollars spent, not dollars lost. Or, yeah. Okay, so then this does have a causal relationship. So you would describe this as buying more gas causes you
To pay more.
to spend more money. Okay, on the back, writing an equation of a trend line. So what we're gonna do is we're gonna graph this and then we're gonna describe it like normal, but then we're gonna create an equation. I'm going to show you how to create an equation from a graph. So this says that you're going to make a scatter plot of the data below. What is the approximate weight of a 7-month-old panda? Based on the data for the panda's weight for the first 12 months, predict the weight of a 15-month-old panda. So first, you're going to take this data and you're going to plug it into the graph. The age is going to represent X. Your weight is going to represent Y. So I want you guys to go ahead and graph this data. Okay, what type of relationship does the scatter plot show?
Positive.
Positive, and the correlation would be?
As his age increases, his weight increases.
As is.
Okay, so
Gender neutral.
as
Wrong. I
the
know.
panda gets older, it gains more weight.
It loses.
That's the opposite for me.
Okay, now what we're going to do is we are going to write an equation from this table. Now, remember I said that when you graph your trend line that you want to make sure that it touches at least 2 points. Okay, yeah, ours touches more. So what I'm going to do is I'm going to choose just the first and the last point of my graph. So I'm going to choose 1 and 2.5 and 12 and 54.9. And I'm going to write these right here. So 1 and 2.5 and 12 and 54.9. Okay. And I'm going to create an equation from these 2 points. By this time, we should know how to do that. Okay. From 2 points, how do I find, what's my first step in finding an equation? Luke, find the slope. So we're going to do y2 minus y1 over x2 minus x1. Okay.
This has been there for months.
What's 54.9 minus 2.5? That's 52.7.
So it's going to be 51.4, right? No, 52.4 over 11. And then we're going to divide 52.4 by 11, and we're going to estimate, divided by 11 is going to be 4.76. So we're gonna estimate that to 8. So we're just gonna go about, no, not 8,
I thought you had,
5.
you wanted, you always
Okay.
tell us to put in a fraction.
Not this time.
We have decimals in our numbers, Jackson. We have decimals in our numbers. Okay,
What is that? Like,
Now-
why do a curvy line?
because it means about,
Oh.
approximately. Okay, now what I'm going to do is I'm going to use my point slope formula. I'm going to plug a point and the slope in to get my equation. I'm going to choose the first point. So y minus 2.5 equals 5 times 5x minus 1. And I'm going to simplify that down to slope-intercept equation so I can find my equation for this line.
Why? Oh, wait, how'd you?
Y equals 5x minus 2.5.
It's a negative 5.
No, it's not.
2.5.
Yes, it is.
No, it's
Shut up.
5 minus.
Oh, it just hurts.
Okay. So now that we have our equation, y equals 5x minus 2.5, we should be able to estimate the weight of a panda at a certain age.
Oh, so X is month.
Month.
Yeah,
Put
so-
7 in the X and then.
Right, so your x represents the age. So using the equation you generated from the previous step, estimate the weight of a 7-month-old panda. So I have y equals 5x minus 2.5, and I'm going to plug the 7 months into the x.
Oh no.
It's 33. No, it's 32.
So about
Five
32.5 pounds.
Church goes on to do it.
Okay. Now I want you guys to do the same thing, but you're going to estimate the weight of a panda at 15 months old. So we'll do the same thing.
Oh, wait.
Bruh.
I'm sorry.
Is it 170? It's
It's
the
like
same.
10, 20. It's 1.
It's
75.
Half a
I
pound.
think it equals 70.
Whoa.
Wait a minute.
That
I messed up. Sorry.
2.5.
I heard all these numbers and wrote.
I don't think it's illegal to have a purple over here because I've seen it before.
Okay, so the weight of this panda would be
A lot.
72.5.
72.5.
okay, and that is lesson 3.8.
Yay! 72.